Welcome to the video for problem 4a from Superquiz 3. In all the problem 4s, we're going to be determining whether a given series converges or diverges. And every time, right, it tells us, oh, you got to cite your test, blah, 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 right? Okay. I say blah, 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 but that's like a really big thing for mathematicians, right? You use something, you cite it. All right, so we'll be sure to do that. All right, so we're looking at a series, and what do we see? First, it has an exponent, which makes me think geometric series, except, oh, it's got a factorial on the bottom. Yeah, I don't want to use geometric series. So the factorial makes me think ratio test. The exponent, aside from geometric series test, makes me think root test. So let's try both, right? Let's do the ratio test first. Factorial just almost always makes me want to use ratio test. So let's try the ratio test. So for the ratio test, I need to take the limit as n goes to infinity of the absolute value, but okay, before we write an absolute value, you notice there's nothing negative up here. So I'm not worried about the absolute value. So I need to look at the ratio of the n plus first term to the nth term. So the n plus first term will be 7 to the n plus 1 over n plus 1 factorial. Then I need to divide by the nth term, and we're looking at the nth term here, which is the same thing as multiplying by the reciprocal, which is n factorial over 7 to the n. All right, we're going to get a little bit of cancellation here. So let's see, there are n plus 1 sevens in the numerator, n sevens in the denominator, so I'll be left with 7 in the numerator. Okay, what about this n factorial over n plus 1 factorial? Well, let's remember, n plus 1 factorial. This means multiply n plus 1 times n minus 1 all the way down to 3 times 2 times 1. And if you just ignore the first term, the n plus 1, this is exactly n factorial on the end. So n plus 1 factorial is equal to n plus 1 times n factorial. So I could rewrite this n plus 1 factorial, right, as n plus 1 times n factorial. And now these n factorials will cancel. And so I'm just left with an n plus 1 in the denominator. As n goes to infinity, n plus 1 goes to infinity. Of course, the 7 is staying constant, so this limit is equal to 0. And the ratio test says if the limit is less than 1, then the series converges. So thus, the series from 0 to infinity, 7 to the n over n factorial converges. Okay, so we've got a solution. What if we had tried the root test, though? So if we had tried the root test, then, remember, we'll be looking at the nth root of the nth term. So I take the limit as n goes to infinity of the nth root of, well, again, you should write absolute values, but everything is positive, so we can ignore that. And I have 7 to the n over n factorial. Now, we know that if you take an nth root of a quotient of positive terms, this will be the quotient of the nth roots. So I can write this limit as the nth root of 7 to the n over the nth root of n factorial. All right, in the numerator, the nth root of 7 to the n is just 7. And then I still have this nth root of n factorial in the denominator. All right, so we had a list of helpful tools for the root test, and one of them was that the limit as n goes to infinity of the nth root of n factorial is infinity. All right, so in this case, the numerator is again constant, the bottom is going to infinity, and so the total limit is 0. And again, we conclude, because the root test, same condition as the ratio test, if the limit is less than 1, then you know that the original series is going to converge. All right, so 2 different ways. Take your pick.